We've just restarted our notebook and we've just run pandas and NumPy here. So let's go down to where we left off. Here we are, reordering and sorting levels. We're going to be working with this hierarchy 2 data frame here, so let's run this. Make sure we have that. And we also need these names that we've given it. So we've renamed our indices, location and color, and this would be the alphabetical key and the numerical key, names that we gave them last time. Now down here, let's run this again so that we can see it. And you can probably tell by the name here what this is going to do. Right now we have the alpha key on the left and the numerical key on the right, but if we run this, it switches them. When we do the swap level, Pandas is intelligent enough to know that it needs to label these. And remember now that this made no permanent change. We did not use in place on this, so if we run this again, it's still in its original shape here, and this is our current state of our data frame. What happens if we sort according to index level 1? If we sort according to that, we get 1s here and 2s on the bottom. And since we've gone and scrambled the alpha key column, Pandas has to fill in to avoid readability confusion. Well, let me comment this out so that we can better compare this next code execution. So here we're going to swap levels and we're going to sort index level 0. So we're going to swap levels at the same time, so it's going to sort on the 0 level after the swap has been made. And the result is to have scrambled the 1 level but sorted along the 0 level. We can apply summary statistics to this same data frame. Let's output it again for inspection. And we're telling Pandas to sum across the number key level. Now we're using the name here instead of the number. We were telling it level equals 0, but down here we're using level equals number key, and level 0 is equal to alpha key. Let's run this and see what our summary does. We're taking index 1 and we're summarizing it. So the summary of the green is going to be 0 plus 6, and we get 6. Summary of the red is going to be 1 plus 7 and we get 8. Summary of the green is going to be 2 plus 8 and we get 10. And likewise for 2, here's the 2's are all summarized. And summary of 3 plus 9 is 12. 4 plus 10 is 14. And 16 matches up with this 5 plus 11. We are summing along the vertical axis here. As we've seen in the past, if we change this to the 1-axis, we're basically just summing up the greens here because the reds were standalone. All the red rows are 1, 4, 7, and 10, and here we go 1, 4, 7, and 10. But the greens are being summed, so 0 plus 2 is 2, and this 8 comes from this 3 plus 5, and the 6 plus 8 leads to the 14, and the 20 is from the 9 plus 11. So those are summary statistics by levels. We can choose which level we want to sum from. Finally, we're going to look at indexing inside data frame columns. Now, from the experience we've had, you might imagine that this looks like it's going to be a hierarchical indexing. We've got 3 1s, and we've got what looks like a sequence there to match. And then we have 4 2s, and it looks like a sequence there to match. Let's run this. And what we're going to do is use the setIndex method to say, okay, Pandas, take the C and the D columns and turn those into indexes. Let's run this and you'll see the result. Okay, just as expected, the C and D have been removed and used as indices. But interestingly, we can keep the C and D in the column and also use them as indices. And that's simply adding this drop equals false attribute. And you'll see that we've retained both copies. Up here we set this operation to be equal to a new data frame, so this has been preserved in memory. Let's comment this out so we can see. right now this is the current state of this df2 data frame. But we can revert back to the original non-hierarchical form by using this reset index method. So let's run this. And there we are back to normal.